Welcome to the second tutorial of Laboratory 5 for IE 574. So the first thing that we're going to address for this lab is the console, because for this one you actually need to print values to be able to debug some things. So I'm going to make you remember, we went through this before, but I'm going to say it again. So I'm going to tell you how to use the console with VRIP. So in Mac, what you need to do is, and this is only for Mac, for Windows I'll address it later. So in Mac, what you have to do is go to the terminal, open it, and remember you had to look for where VRIP was. So you go for your VRIP application is, and then this is where your VRIP application is installed, and this is the icon that if you double click you would launch VRIP. So you click it with your right click, and then you go to show package contents. Then you go to contents, Mac OS, and here's the actual executable of VRIP, all right? And all of this is where VRIP reads files. So every file that you read or write, it'll be written in this directory that you have. Okay, so to initialize VRIP, what we have to do is just put the address of where this VRIP is. The easiest way to do this is if we right-click the executable and go to Get Info, and just where it says where, we just copy it all right? And what we do is we paste that, then do one more slash, write VREP, all in like this. We just write VREP, and then we write a semicolon, write exit, and a second semicolon, and that would be it. Okay, so this console is where you'll see the things, the elements that you printed on Mac, okay? For Windows, it's so much more easy. Since this is in Mac, this won't show me the actual option, but for Windows, the only thing that you have to do is after you open VREP the regular way that you're used to, you just go to the settings here on the left side, and in here, okay, so in this space that it looks like something's missing, you should be able to click to select the show console or display console. So for Windows users, this is the only thing that you have to do. Open VREP normally and click in here this option that it doesn't appear about showing the console. Okay, so now I'm going to open the sample scene that I have published for you through Blackboard. Okay, so what does this scene do? I added a proximity sensor in here. I don't know if you can see it. It's the pink proximity sensor that it's here. And when a piece comes, this camera will take a picture when it's detected by the proximity sensor. And what I'll do with this image is that I'll go through every pixel, and the first pixel that I find that actually belongs to a chocolate, depending on its position, I will send the message with the position of this pixel to robot 1, robot 2, or robot 3. Okay, so I'll go over in detail later. The first thing that I'm going to show you is that for this scene, I made a little bit of extra functions for you that I think could help you. So now let's open the blob detection camera so I can go over the code. So in here there are a few things that are new for you. The first thing is this variable that it's here that is first time. And I explain later what we do with it. Okay, so let's go to actual functions that we made for you to make your life a little bit easier. So we have new functions to get and set pixels. This is get normalized pixel and set normalized pixel. So basically these are the same as get pixel and set pixel, with the difference that instead of using values that are from 0 to 255, this is actually using values from 0 to 1. We made these functions for you because later we're going to show you how to view the image that you've been manipulating or that you've saved. And to do that, we need to have the image normalized between 0 and 1, the pixel values between 0 and 1. Right, so the other functions that we made for you are this save CSV function and trim image function. So the save CSV is very easy. It saves an image into a CSV file. So the parameters are in here. You give it the file name, and later you see an example because we use it. The second parameter is the actual image that you want to save into a CSV, and the third one is the width of the image. With width, I refer to the number of columns that this image has. Since we're working with a square image, it doesn't matter much, but if at some point you'll be working with a rectangular image, this would be the number of columns that your image has in your matrix, all right? So the other function is trim image. So this will basically return an image that is trimmed by the parameters that you give it. Sometimes you don't want to work with the whole area of a picture. Let me play this a little bit so you guys see what I mean for a second. So this has this white elements in here that you don't need to detect, and also you might be interested in a smaller area of the picture. So this lets you trim this picture into a smaller area to work in it. All right, so I'm going to stop it. So what we're doing here is you give it your original image, you give it the position of the X. So let me play it again so you see what I mean. For example, if I wanted to work in this small area of here, I would give it the position of the starting X or the starting row, the position of the final row where I want to trim, and then I do, so this is starting row, final row, starting column, end column. So X0 and X1 would belong to the start and end rows, so it would limit it vertically and it would trim it vertically, and Y0 and Y1 would be the start and end columns, so they would trim it horizontally. All right, so this is your horizontal of it starts here and it ends here, and you could trim it to a smaller range. Right. We have an example below so you get a better grasp of what these can do. Okay, so now we're going to go to the actual code. So what we're doing with this code is this already you know, and it's the same that you've done before. The code that's new starts in here. So I'm going to separate it a little bit. So this is all that you had before, and it's explained in the first tutorial. In here, what we're doing is detecting if the proximity sensor has something. So this reads the proximity sensor, and this function checks if there is anything or if the camera has detected an image. This check is done because when we first start the simulation, there's a period where the image might be gray, and if your computer is slow, it might be a long time. So this is just checking that there's an actual image to check out. And this is checking, okay, so I'm not gonna do anything as long as this proximity sensor doesn't detect anything. So once I have an image and I detected something, I'm going to do this. This is the trick that I'm using to only detect the element once, because let me play it for you so you understand what I mean. when a piece comes through here, it'll be sensed by by this proximity sensor several times, not in just one cycle, but in several cycles of this program. So it'll be detected as many times. Like probably this would detect it 1, 2, 3, 4 times probably. So I just want to detect it once because I just want to take one picture. So what I do, if I check, is this the first time that I'm detecting this image? If it is, then I actually execute my code and I immediately set my first time to false, so I don't enter here again. When does this value come true and allow me to enter again? After I don't detect. This code is for when I detect an element, and it'll enter in this piece of code when it doesn't detect anything. So it'll be the first time variable will become true again when we are not detecting anything. This logic of the first time variable guarantees that it'll only take one picture per piece. Okay, so the first thing that I'm doing after we detect a piece and it's the first time that we're detecting it is we save this image. So I'm going to use the function that I write for you in here. So the image would be image.csv, and as I said, first you give it the file name, then you give the image. The image was detected previously in this with the SimGet Vision sensor image, and you give it the width. In this case, width and height is square, so it doesn't matter which one you give it. And I'm going not only to save the image, but I'm going to save a trimmed image too. So what I'm doing here is I'm going to save, this is a save CSV, I'm going to save it as trimmed image. And in here, instead of giving it the regular image, I'm giving it a trimmed version of the image using the second function that I gave you. So this trim image is receiving my regular image and is trimming it into a 100 by 100 square that starts at row 76, ends at row 175, and then starts at columns at column 76 and ends in column 175. So what this is doing is, and I have a screenshot, if this is the image that I'm getting, this would, if you counted down 75 pixels and then counted from left to right 75 pixels, you would have your start point, and then you would go from 75, 75 or 76, 76 to 175, 175. All right, you'll be getting a 100 by 100 image, so you would be getting something. Oh, this is not to scale with the actual image, but you would be getting a square. That's something like this. All right. Let's go back to the code. Okay, so we're saving these two images, and what I'm going to show you first before we go to the rest of the code is how to actually see these images. All right, so you can check what your camera is seeing, and if you did any modifications, you'll be able to use this function later after you've modified your image and see it in Matlab. All right, I'm going to put this to a side and then hit play. So this code will happen every time we detect a piece. It happens first. The conveyor belt is running. I changed the drop-in pace a little bit so it would be slower for this exercise. Okay, so when I detect a piece, the conveyor seems to stop, but the whole scene is stopping. So this is because my computer is a little bit slow. So what it's happening is that the whole scene freezes a little bit every time I do this processing. Okay, so let's stop it there. And the image that I have would be of the L-shaped square, L-shape that we got the second time. Okay, so this is constantly overriding because it has the same name. So every time this is happening, it's overwriting the last save image. If you want to save all of the images that you're getting, what I recommend you to do is add an extra counter in here. So you could do something like counter count equals 0, and then in here you could split split your string to where you want to add the counter number, and it could be, for example, an image, and then I just attach the number 0. So these 2 points are the operator of string concatenation in Lua. So what is this doing is this is going to, oh, this is not 0, this should be a counter. Alright, so what this is doing is that the final file name of this will be image underscore and then the counter. So I'll do the same thing. I'll attach counter to the name, and what we need to do after this is increase the counter by 1. Counter equals counter plus 1. Okay, so this is what you would like to do if you want to save every image. All right, every time the code goes through this part, what it will do, oh, the counter shouldn't be initialized in here because then it would become 0 every time it enters. It should be initialized in the initialization part of the script. So it should go actually in here. All right. So everything that you want to be initialized just once, you initialize it in here, and then you go down. Okay. All right, so let's check out what we've got. So what we need to do now is we're going to use Matlab for this. So if you already have Matlab, this is great. But if you don't, what you can do is you go to Purdue. You just look for Purdue Matlab remote. Purdue has a remote tool that lets you use Matlab remotely. So we navigate to here where it says, and it'll ask you to install this. I already did, so I'm going to just skip to the logon, and you guys can log on with your Purdue account, and here you have Matlab. So if you double click it, or if you click it, it'll have this launch.ica, ICA. So if I open this, and I already downloaded the software, this viewer will open, and you'll be able to use Matlab remotely in your computer. So it's starting the application. And it works just as if you had Matlab in your desktop. Alright, so I actually have Matlab in my computer. So instead of using this version, I'm going to use the version that I have in my computer. So I'm going to close this. Disconnect. Okay. So this is the Matlab that I have. And what I'm going to, this is my command. For seeing the image, you only have to load the image, turn it into grayscale, and show it. It's 3 simple steps. So the first thing that we're going to do is load the image. And what I have to do is I have a variable image. I do load, and I just, the only parameter that load would take is the location of the image, okay? So for us, it would have to, since VREP saves all of the files in the same folder where the executable is, you have to do the same thing as we did in the beginning and copy the whole address up until where your executable should be, and then we're going to load the image. Okay, so let me load the regular image first. So we're loading image.csv, which corresponds to this saving that we're doing here. I'm actually going to go back to the original code one because I've already cleaned this. So it goes with the, so it corresponds. Okay, so we're first going to load this image that we saved here. Remember that we saved an L shape, so it should show an L shape. So we load it first, so it is just your variable equals load and then the location of your image. It prints it. Then what we have to do is just do transform this to the Matlab grayscale. So what we do is you have a second variable and you assign it to, this is a function, is mat to gray. So mat to gray receives your regular image that you loaded and it'll transform it, or your regular CSV that you loaded, and it'll transform it to a grayscale image that is understandable by Matlab. So this is doing the encoding into an image part. Okay. So there we go. So you can see. And the third thing that we have to do now is we just have to show the image. All right. So the third element is this function that's called IM_show, and we show our grayscale image. So I hit click. So here we are. This is the L-shaped image that we got. We can actually check our trimmed image now. Oh, before we check our trim image, one of the cool things that this has is that if we click on this type of tool here and you click an element, it'll give you the position XY. So it'll give you the row and the column number or where this pixel is in a matrix, and it'll also give you the index. So if you want to do thresholding, you can kind of check around and see what would be a good limit between this index and this index. So see, this index are between 0 and 1. So as you can see, this is very close to 0 because it's almost black, and this is very close to 1 because it's almost white. So this will help you know where to do the thresholding. All right, so now let's see the trimmed image. So we have to do the same. We have to load our CSV first, and this time instead of image, it will be trimmed image. Then we transform it to grayscale, and then we just do IM_show of our image. And as you can see, this is just a 100 by 100, and it trimmed it, and we can see only a piece of the chocolate L shape. So I just randomly picked 100 by 100. I just picked coordinates that would make it 100 by 100 image randomly, but you guys should adjust it according to your needs. So now let's get back to what the rest of this code is doing. So as I said, what we're doing with this image is we're going to go through the matrix of our image. Let me go again to explain it with this one. To grayscale, and then show it. Okay, so what we're doing is we're starting from here, and we're going through the first row, column by column, then through the second row, column by column. As you can see, this goes, I represents the column, the rows, and J represents the columns. All right, so we're going first row all the columns, second row all the columns. So we're going through the matrix like this: first column, then second row, then third row. So what we're doing is The first thing that we do is get the pixel that in the position that we're checking right now. And then this get pixel, since I'm not using the normalized version but the regular version, this will give me a value between 0 and 255. And what I'm doing is checking if the pixel value is less than 100. If I do this, it's very likely that a pixel, if the value is less than 100, it's very likely that the pixel that I'm getting, it's a chocolate. It's part of a chocolate, all right? So what I'm doing is, if the pixel value is less than 100, this means that I detected a pixel that belongs to a chocolate, and I'm going to print in, which means inside this if condition, just to check, just so we know that we're here. And what I'm going to do next is print the position of this pixel, all right, which belongs to the two loops that are going through the matrix. And then what I do is I check the J position. So what I'm doing is checking the column that this pixel has. So for this particular matrix, what would happen is that in here I would be not detecting anything, and then when I go to this row, this would be the first pixel that I detect that belongs to a chocolate. And if I click it, this is the pixel in position 9046, so row 90, pixel column number 46. So what I'm doing here is checking if the pixel column, if it's less than 100, what I'm going to do is send the signal to the first robot. If it's between 100 and 120, I'm going to send the signal to the second robot. And if the position of this pixel is more than 120, I'm going to send a signal to the third robot. So why am I choosing J? Because J is well determined the position that it's interesting for you guys to know where to pick the elements. We know that it will be moving through X, because as the conveyor belt it's advancing, this will move through the X. This will move through the X axis, but we're not interested in that, because what you guys will do is you'll probably put a sensor and you'll detect when the piece goes through there. What we're interested is in the position in Y, which belongs to this J in here. So this is not exactly what you guys have to do at all. This is just an example that if the first pixel that I see is closer to this bottom, it'll activate the first robot. If it's kind of in the middle, it'll activate the second robot, and if it's closer to the top, closer to the robots, it'll activate this third robot. So what I'm doing is, as you can see, this signal is robot signal 0, because this robot is the first one. Then this is the IRB 360. Then I'm sending robot signal, because this is the IRB 360 and it doesn't have anything. And this is the IRB 361, so I'm calling this signal robot signal 1. This doesn't have to do, I just put it like this so it would be easy to relate it to each robot, but you can put in here any numbers that you want or any signal name that you want. Okay, so what I'm doing is I'm not only sending a signal, but I'm actually sending it with a value, all right? So what I'm doing is I'm sending the position of the pixel, of the detected pixel, to each robot, depending on where the pixel was. So with each image shot, I'm sending a signal to only one robot, depending on the position of the J, which is the position of the column of the pixel in the matrix. All right, so this you don't have to do at all. This next part, this is a break, and what I'm doing is I'm just interested, for the sake of this exercise, in the first pixel, and then I want to leave this loop. So what I'm doing is I break the first loop with this instruction in here, so this gets me out of this first loop. it doesn't let it continue until it gets to the final number. It stops it immediately. And this second variable in here will let me stop the outer loop, the first one, the one that is going through the rows. So if you're not interested in stopping early, if you want to go through the whole matrix, you just have to comment all of this stop. The stops and the breaks, you're not interested in them, and you can completely delete this if that it's here, all right, if you want. So I'm just doing for the sake of processing time, because if I go through the whole matrix and since I'm saving 2 images, it gets a little heavy. Okay, so now let's go to the robot code. So the robot code is exactly the same for each robot. The only thing that it changes is the name of the signal that it's waiting. So let's go to the first one, and if I open it, and this is exactly the same, it just has a new target home. So let's check what this robot would do. So this is what we already had, the set in IK mode, and what we're doing here is we're trying to get the integer signal, robot signal 0. All right, so we're reading that signal. What will happen if no signal has been sent? This will give me a null value. All right, so and when it's set, it'll give me the J value. It'll give me the position that I sent. So let me open both codes at the same time so you can see it. Okay, so if the position of the pixel in Y in columns is less than 100, I'm going to set a signal to this robot signal 0, so to IRB 0, all right? And the value that I'm going to get in here when this signal is set is this J over here, all right? So it'll be the position in Y of the pixel. So this is how you send signals to your robots, and this is how you will be able to indicate the position where your element is. So you can do some translation to the actual coordinates in the scene and be able to pick it up. Okay, so if there's actually a value, if this signal was actually set, we then enter into this part of the code. The first thing that we do is we clear the signal so we don't execute this code again. And what I'm doing here is I'm just doing a little print. I'm printing the value that I got, all right? So this robot 0 value, this print should be the exact same value that I'm reading in the blob camera script. And then I'm just going to move to the drop position and back to the home position again. This is so you see visually which robot is detecting what. So I'm going to hit play the scene, and I'm going to put the terminal in here so you'll see the printed values. Okay, so the first thing that we get is we get this print in, and we detected the first chocolate pixel at position 4795, and as you see, the robot 0 got the same value, 95. Now, since the position is 44, the 144 in Y, this is a robot that it's moving. And you see the robot 1 got the element 144, this value. So let's see. This is 90, so it'll activate the first robot. And since this is random, at some point we'll get one that will activate this middle robot in here. Maybe this one will do it. So yes, this will activate the middle value. All right, so this part is being printed from the blob detection camera, and this part is being printed from the robot. And as you can see, this value is being transmitted successfully. Oh, cancel. All right. So this sample scene, it's allowing you to know how to iterate over an image. You can now save your images and check them in Matlab and see what you're actually detecting. And you know once you've detected, for example, the centroids or the position, or you've detected which one of the pieces is you've recognized the piece that you want to use. Now you know how to send each value of each signal to each individual robot and send additional information that will belong to the position to the robot. Okay, so that'll be all. If you have any more questions, please post them in Piazza. Hope this tutorial will help you to make the transition for this part a little bit more easy.